Hello, everyone. Welcome to today's webinar. We are going to be focusing on an introduction to terrain tools, or if you're a user of Roadeng, we'll be focusing on an introduction to the terrain module. So this webinar is going to cover a whole bunch of different functions inside of terrain, and we're going to kind of split it up into two pieces. So our agenda for the next 45 minutes, in the first half, we're going to focus on talking a little bit about data import, an introduction to terrain modeling, and probably our biggest piece of that is going to be chatting about feature properties, what they are, how you can set them, and really the importance of using them when it comes to working with your data. The second half is going to be diving a little bit deeper into sort of more of that site design and grading side of terrain. And here we're going to be discussing layers, both layers inside of a terrain file, as well as how you can layer terrain files in order to create different site design and grading projects. So we're going to be taking a look at that, and a great example shown actually from one of our clients here on the screen from Almer Construction. We're going to be looking at a similar pond example for site design and grading. So as I mentioned, today we're going to be focusing, really exclusively on the terrain module. And just a reminder, our software is modular. So, if you've got Roadeng, you're going to have a few different applications that come with the program, different executables off your desktop. If you have just terrain, you just have terrain. So today we're just going to focus on the one module and really talk about it in depth. So a terrain model is an essential first step when it comes to corridor projects. And we talk about it in probably every single one of our webinars. We create our TIN. Well, a terrain module can be used for a lot more than just the creation of that TIN. So again, today, hopefully we can impart on you a few different concepts and a few different workflow ideas for how you can leverage the platform to be able to do more than just creating that original ground surface. So the terrain module, as I did just mention, uses an original ground surface, and it can come from a variety of different data sources. So this could be from LiDAR, from drone, from a DEM that you've been able to get from a publicly available source. It could be from conventional data, whether it's an RTK or a total station, or perhaps you're bringing it in from another software. So in that case, we can work with a DXF, a DWG, or a land XML file. But today, as we kind of get into talking about modeling and about those key feature properties, conventional data is really the best place for us to work with. So if this is, typical total station data, and we're going to show you how to import it, how to improve some efficiencies when you're working with it, and how to create some of that line work that's really, really important for the creation of the accurate TIN model. So conventional survey data typically imports as points, and these are going to come in from a text file, a CSV file, some type of ASCII file. And when you bring them in, they're really just a bunch of points that typically have associated point codes. In the terrain module, we can use something called an IOP file that can really help us describe to the software how to interpret that data, and really can help us determine sort of what columns the data is in, where your X, your Y, and your elevation are, as well as it can help us to automatically join features and create polylines, even defining line work and symbology. So these IOP files really do help us take a bunch of points and turn them into meaningful features, line work, as we look to create our surface. So Matt's going to be covering in our software part that's going to follow this sort of little introduction. Matt's going to be covering working with conventional survey data. I just wanted to sort of double down and reiterate the importance of being able to set features through that IOP, and in particular, break lines. We're going to talk about break lines in a couple slides from now in a bit more detail, but they really are useful at managing the way that triangles are formed in your TIN surface. So your TIN surface itself is made up of a whole bunch of triangles connecting your known points. And break lines really do define the way that those triangles are formed, and that if there's a break line present, a triangle cannot cross it. So we're able to define these break lines as long as we've got data that's been delimited with different point codes. Being able to define that on import to be able to create those break lines, making a much more accurate model for us to work with for our project. Break lines are one type of feature property, and this is the other sort of big piece that we're going to focus on in this first half of the webinar, is really these different feature properties. And you can see them in the feature properties panel. There's a whole bunch. These can be different types of terrain modeling properties, visual properties, as well as attributes. And we can set and control the properties in order to control how the feature behaves, essentially. And some of those key feature properties include displayed. So there's two of them for displayed. We can control whether it's being displayed in the plan and profile, or whether a feature is being displayed in the 3D. And this one's really pretty much not, do we see it, do we not see it, is what displayed is. And it can cause a bit of confusion with the role that it plays. So that's displayed. Elevations is one of the key ones. Now, this is a feature property that we use to control whether the feature uses its own elevation, or when disabled, that means that the feature is draped on the model. And this example here shown on the screen is a thalweg, and it's draping on the model. So we're able to bring in different features into the software, and you can set that property whether to keep their own elevation or disable it and drape them on the tin surface. And when you're working with feature properties, I find it really useful to look at the cute little picture on the side. It helps us get a good sense of what that certain combination of feature properties is going to do to the feature. So if it's modeled, it's connected, it's displayed, but elevations are turned off, we're going to turn into a draped feature. The other one I want to include before we go back and talk about break lines is a little bit more about modeled. So if it's enabled, that means the feature and its elevations are being included in the tin model, as long as you have elevations turned on. So in a draped feature, obviously we're not including that in the tin model, but if we've got modeled included, that means it's being included in the tin and being used to calculate the surface. If it's disabled, it's going to be excluded from the tin model. And contours that our software creates are a really great example of features that would have modeled turned off. Because we're calculating the tin from the known points, those contours are simply being interpolated from that tin and therefore not being used to go back and recalculate it in the future. Okay, circling back to break lines. So break lines, as I said, super important, especially when we're working with conventional survey data. And these really are lines in a tin that are going to represent a distinct sort of interruption in the slope. A great example, we've got a road edge, a road center line, possibly an edge of ditch. These are things where we really want to make sure that they are not having triangles break across them. Because when triangles break across them, it causes strange edges. So when we use a break line, it's really telling our model to make sure that triangles do not cross that edge. So yes, very important, especially in particular when working with total station and conventional survey data. So this is just a quick look at what that process might look like. You can take from Excel or a CSV here a bunch of point data. That point data's got a point number, it's got an elevation. Over here in column D, it's X, it's Y, as well as its point code. And we can take that and using an IOP, we can translate that into a model. And that's where we're now going to pivot into sort of the first half of our webinars in software demonstration and take a look at modeling in a little bit more detail. And with that, Matt, I am making you the presenter.
Great, cool. So just to start, we're not going to dive in right from square one or anything like that. We're going to just look at how all that stuff Aaron introduced actually works in the software. So right now I have a conventional survey data set in the software. I can click on these points. I can see that there's properties associated with them. I can see the symbology assigned to them. This point that I've clicked, it is a feature with 1 point in it. It has the cross being applied and it's named GND. Now, if we click on this feature here, I can see that again, I have one feature selected with 10 points in it. This one is obviously a line. We can see it's a line. We can see the line work being applied for that line, the properties, and the feature name. And this one is BOB1 for bottom of bank. Now, of course, you may want to know where that stuff is in the plan view, which is the view I have open to the left. But we probably want to surface from it. So to take that survey data and turn it into a surface, I'll click Terrain Modeling, Generate, and I'll hit OK. So here, well, we've got something in our 3D view that isn't just the 3D points and polylines. And we also have our contours being generated. So we can cruise around and we can see what it is that we're dealing with here in this file. Now, the surface that we create is a tin surface. And we'll turn this on just for a brief second to talk about it. But of course, tin, triangular, irregular network, so we can see all those triangles that are making up that surface. I'm going to turn that off because it's a little hard to look at. Now, the properties that are introduced, we'll just kind of step through those and see how they interact with things. So to start, I can see all of the features in my model here. I'm going to click Select Feature by name, and I can scroll down here and I can select individual features if I'd like. But what I want here is I want all the ones that start with being called GND. So I'm going to GND, asterisk will get any names afterwards or any extra characters afterwards, and I've selected all my ground points. So here, if I want to still be able to see those in my 3D view, but those ground points aren't really adding a lot of value to my plan view, well, maybe I don't want to display them. So I still want them in my model. I don't want to see them. We can turn off that display plan profile property. We can hit apply. So everything that we're looking at, we can still see it because they are still selected. If we click off to the side though, they appear to be no longer there. Now, if we want to select all those, select everything or see everything that might be hidden in our model, we can right click, select all, and we can see all those hidden features now too. I'm going to turn the display property back on for everything. So display in 3D, well, that behaves very much the same way. I've got this feature here. Let's zoom in a little bit more. This feature here, well, if I don't want to see it in my 3D view, I can turn that off and it's not there. Now, of course, I do want to see that, so I'm going to turn it back on. And the next thing that we'll talk about here is whether it's included in the model or not. So that point that we were just looking at, this one here, we can look, we can see underneath it, it's not included in the tin surface. So modeled is turned off, but elevations is turned on. So it's still a 3D point. It just doesn't affect what we're using our tin for, and that's to represent the ground. Now, if we turn this back on, hit apply, and remodel our surface, we can see, well, that's not really what we'd like. We've got the road there. That sign really shouldn't be included in the model. We turn it off, we hit apply. It tells us our triangles will be cleared. We click generate, and we redo that surface. So that is model being toggled on and off. Now, we could have a feature that didn't have elevations with it. Now, it's not going to be very interesting. It's just going to be a 2D feature. So if you had, say, a shape file with no elevation data in it, and you brought it in, well, it's just plan view line work. You don't have to worry about it. One thing that is really worthwhile to talk about here, though, in the interaction between elevations and modeled is the draped feature functionality. So I'm going to just zoom out here. I'm going to go over here. I'm going to draw a new feature. I'm going to just say, I'll give this a name. I'm going to create it with my mouse. And sure, we'll go from there to there. Now, this feature is floating above the ground. We can see it's a straight shot from there to there. If I was using terrain to cut a section, well, we can see the section of that feature, but we probably wanted to see the actual elevation profile of the ground underneath it. So in that case, we would turn elevations off. We'll leave modeled on. So what we're telling the software is, well, it doesn't have its own elevation data, but we want to pull that in from the model. We'll hit apply. We see it's clamped to ground in the 3D view. And if we go in here, we can see what we're dealing with. And one really nice thing about this is it's dynamic. So if I pull this over here, we can see our profile changes. So if we want to check things out, pull different things around and see what the ground's doing underneath it, we often use draped features. And for our forestry clients that do cable logging, if you were running a D-line, you'd run it on a draped feature. Now, I'm going to get rid of this. So I'm just going to select it. I'll click delete on my mouse or on my keyboard. And the next item on our hit list is break lines. So this surveyed line here is a break line. And what that's doing is that's keeping our triangle edges from crossing it. So if we had something that wasn't a break line, so it could be like a drip line around trees if you're surveying that. It's really not influencing the topography, but you want to see where it's at. Not all lines are going to be break lines. But if you're using lines to represent abrupt changes in topography, well, those will be your break lines. I'll turn break line off. I'll remodel this thing. And we've got these triangles that are crossing the feature. So at the most fundamental level, that's what they do. They keep triangles from crossing. So we've got that. And really, we can change our line work. I'm making that a heavier line. We'll change our symbols at that feature. We can hit apply. We can see the change takes place. But those view properties are the most important ones, and you can do a lot with just those few. So with that, I'll hand it back to Erin, and yeah.
Awesome, thanks, Matt. This next half of the webinar, we are going to focus on kind of taking that initial foundational model and going a little bit further, talking about site design. And we first wanted to stop and have a conversation, or at least introduce the topic of layers. And there's kind of two ways that our software can handle layers. The first is layers within a terrain file. Now, you can create different layers, and this is designated by sort of a matching string, as you can see here in the screenshot to the right. So you can create layers within your file that makes selecting and working with groups of features easier. Now, typical layers that we have automatically defined as if you've got contours, if you've got streams, for example, those are going to show up as layers. But you can create and define any layers that you would like within terrain. So we'll talk about and show you a little bit more about working with layers inside a terrain file. But the more important concept today that we hope to impart on you is that you can actually layer terrain files themselves in each other. So when you put terrain files in the background of another terrain file, it does a couple things. First, you can see it, so it's visually shown. As you can see here on the example that I've got on the right, this is a live maps image, and it's brought in as a background terrain file. We can control whether it's displayed in the plan and the profile, and it's really, really useful for adding context. But today, we're going to be focusing on that sort of more site design side of things, where we can actually put, for example, an original ground file in the background of another terrain. And the reason you'd want to do this is when we start to get into site design. So you don't want to modify your original ground per se in its own file, in the original grounds file. You actually want to modify the original ground with a surface or changes to that surface, but do so in its own file. So in this terribly worded example, we've got sort of in terrain number 1, you've got your original ground, and I'm looking at a profile here just to add some more context. In a second terrain, we could design a surface knowing with this terrain in the background, so we can see it and we can design to it, being able to calculate volumes, being able to, interact with that surface, but without directly modifying it. So in this example, terrain number 1 is in the background of terrain number 2. And this becomes really, really useful when you're wanting to do projects like a pit, a pad, a pond, anything that we're modifying the surface. So in this example here with a pond, in the background, and you can see the contours from it, in the background is the original ground surface in its own terrain file. And then we create the new surface and we grade and interact with that surface in a separate terrain file. So a little bit of a fun concept, much, much easier seen through a software demonstration. So I'm going to pass it back to Matt now, and we'll go into the software again, take a look at site design and grading, and I think we're going to be doing a pond example.
All right, so I am going to start right from scratch here. So that last part where I was in the software, I just wanted to cover concepts. We're going to go right to square one with our survey data. So we can see our survey data. Now this survey data that I have is in a CSV. So if I open that in Notepad, I can see, well, I've got my point number. I've got my, so CSV stands for comma separated value. I can see my commas separating the columns. I've got my easting, northing, elevation, and point code. So we're going to open up terrain. We're going to click insert file. We're going to grab that CSV. And just to start, I'm not going to build an IOP. So I've got this one. It just so happens my columns are right. It's not accounting for any of my point codes. I can click OK, and voila. Now we can still click along here. We can see what those different features are called out, but they're all getting the same, same symbol. They're all brought in as points, and we'd have to connect the dots, which really it isn't all that bad. We could come in here, we could right click by name, and if I want to select all my centerline points, I can scroll down here, select, and I can click modify, join. Oh, I've got another shot way over there selected. So if I want to break that, I can right click, modify, break, add current point, edit points with mouse, and I'm going to get rid of that vertice for that one. So we can totally go through and we can build everything from scratch. We're not going to do that though. And I'm just going to exit out of here, and we're going to build out an IOP so we can save ourselves a bunch of time and just messing around. Now, when I build out this IOP, an important thing to note, We don't have to do it every time. So assuming you're using similar point codes and similar export options from your survey data, you can build an IOP to match your own in-house standards, and then hit save as default, and it'll be there next time. So here, I could modify that one. Instead, I'm going to create a new one. So got that selected. It's going to use it as a starting point. I'm going to call this webinar. I'm going to come in here. I'm going to set things up. Now, with this, I'm going to go back and forth a little bit here. My easting, so my X column is the third one. My northing is the second, so that's good. My elevation, that guy there as our fourth column, and then our codes are being brought in. And here, if I want to include my point number as an attribute with those points, I totally can. I can add in extra attributes that I want in here, and we'll say, well, that attribute is coming from column 1. Now, mentioned it, but I'll mention it again. They're comma separated values. So it's exported that way, great. Could it be tab separated, space separated, or something really unusual? Whatever it is, you can assign the delimiter in here. And another thing worth noting, I have no header in this file, so I don't have to worry about skipping lines. But if I did, I could say, well, I've got a header that's 3 lines and it's going to skip it. The real value of an IOP, aside from just being able to bring in your data, is streamlining it with the use of point codes. So if we don't have a point code, everything is going to be brought in with the default value. I'm going to hit add. I'm going to say, well, we've got some point codes called thal. Let's bring those in. So I'm going to type in thal. If I had it surveyed thal1, thal2 for different features, I can account for that by adding in an asterisk. So thal1 would be connected by code. And here, if it's surveyed this way where they use the same, well, they surveyed the feature in order, we'll connect it by adjacent in the list. And we could also just connect it by code if it was not worried about adjacency. We'll make this break line. So we covered what the break lines mean. It's going to be 3D feature. It'll be displayed, included in our model. We're going to change our symbol here to be, usually thals are blue. And there we are. Now I'm going to click add. So this one doesn't have a ton of point code names in it. So I'll run through all of them just for the sake of completeness. So BL, BOB, let's make our bottom of bank, sure, that color there. CL, now I like my CLs to be red, my lines to be solid. So my road edge features, and these were separated RE1 versus RE2, so we don't have to worry about lefts and rights or a bunch of extra features. And TOB, and I'll make that purple. Lastly, I'm going to go in here and we have those GND features. Those are my point shots, great. I just want these to be that. Now anything that we don't have accounted for, we're going to make it a big, obvious blob, and away we go. So we'll hit OK. So we've assigned how that IOP gets read in. If we're constantly working in the same area with the same coordinate systems, well, we might as well set our default coordinate system for this file too. So UTM, this one is zone 13. We'll hit OK. And then once I'm done, if I want to have that the next time I jump into the software, I'll hit Save as Default, and it'll just be there. And I'll never have to do it again unless I want to add to it. I'll hit OK. I'll hit OK. So now we're actually importing our file after we've set that up. We can see now we've got a few more tabs. Vast majority of the time, you don't have to worry about these other tabs unless maybe you wanted to do a transformation for your projection, but we're good here. So there's our file. We'll click Generate. We'll create our tin, and we are in business. So no need to play connect the dots. We're set. Now with this, we've got our data brought in. Let's touch on that layer aspect. So layers in Train, as Aaron introduced, we can treat features as part of a layer. So if I right click, select feature by layer, I can see I've got some system defined layers in here. I've got my contours. I can see I've got 75 contours. If I want to create a new layer, say I want all those ground points to be on a layer, I can go in here by layer, layer, new, GND. I'll hit OK. So we've got all those on a layer. And now we can select feature by layer, and we can select them that way. Now, personally, and a lot of others that use Train a lot, unless it's something special, usually just rely on a common naming convention. So here I don't have to worry about assigning layers. I can just find them by the name. And if I don't want to scroll, I can use that advanced tab to select them. Now, one of the nice things about using layers, though, is instead of having to type anything in, you can come down here and say, well, let's select those layers by name. Let's move on to Train files as layers. And for that, we're going to consider them as backgrounds. Now I'm going to just save this. So I've saved that as my topo. I'm going to bring in a background file based off of some imagery here. I'm going to use Bing because it's a little more, well, less up to date with my survey here, which isn't super recent. So I'm downloading this image. Now it's working because I've got projected data. Let's go on here. Oops. And there we are. So I can't just click that image to see it, but I can right click, plan options, background, and my image is in as a background here. I think I was being a little careless. Where did I actually? Okay. Cool. So that's setting up our topo and working with layers in the topo file. The next thing that we're going to do is we're going to move on to using Train for design, and we'll get into that pond that Aaron introduced. So building on all the stuff that we've covered here, I'm opening a new Train. I'm going to right click, background, add. I'm going to add that original ground in as a background to this one. Great. Now, so that original ground has my topo surface, but I'd like to use this new Train file as my design surface. So we're going to start by coming over here. I'm going to say top inside. I'm going to define this feature with my mouse, and I could draw it in, but here I'm not going to, because I'd rather have something nice and geometrically square. So let's go into our coordinates. I'm going to just define this by dimensions. So I want this to be, let's do 50 by 80. So I'm defining it with my azimuth. And then we'll go south. And I'll hit modify, close. Now I'm going to just tile these so we can see a little bit better what I've got going on. So I'm drawing that. Right now it's way down at an elevation of 100. My tin surface, and I can see by hovering, it's up at 795. So let's move this a little handier to our surface. So I'm just shifting this feature up. Now, if you were noting the geometry we were dealing with that example Aaron showed, well, I'd like to have a berm around the top of this thing. So this feature, we're going to buffer it. There's a direction associated with it. So I'm checking my directions here. So as I move up, I want to add the berm to the outside. So I'm going to buffer it to the left. Buffer to the left. We'll make it nice and square. We'll give it a 4-meter top. So that's also a break line. This is going to be top outside. Now for the inside of this one, we could grade to the inside. I'm going to buffer. So we're going to modify buffer to the right this time. I'm going to put my buffer on a grade. And let's make this thing 4 meters deep. So we'll go 16 meters to the inside. And just so I don't go too far without being abstract, that's what we're dealing with so far. And so far, I'm completely below that surface. So I'm going to just, again, more so people can see what I'm doing. We'll make this nice and transparent. So I could have a berm here. Now I probably want this thing to be, I want it to be square, but I don't want it to be oriented that way or exactly where I have it put. So I've just got everything selected. I'll go move. I'll just move this way. I'll pull it up here, and maybe we want to rotate it a bit. So with everything selected, we can do that. Now here, we can shift this whole thing up and down. So I'm going to just go, let's go 794. So we can see what we're dealing with, but I'd really like to have my actual slope lines coming off the back of this. So instead of using the buffer tool, I'm going to use the grading tool. So I'm going to grade to the left. I'm going to tell this thing to target my terrain. Now on the outside of this, I don't really care about my slopes. I'll just leave them at 1-to-1. I'll set this to be 5-meter spacing. We'll go with that, and we'll calculate our volumes here at the same time. So we've got our geometry. If we want to see those volumes, we can click over here. And I've got a lot more fill than I have cut. So usually a pond is either going to have more cut than fill, or you're going to want it balanced so you don't have to worry about moving stuff around. So let's get this thing to balance. And so instead of using the grading where we're just using that existing elevation, we'll come over to our optimization tab, click auto balance. We want a surplus of 0. Great. So now this thing's balanced, and what it's done is it has moved it up and down until we have enough cut from in here to build those berms up on the outside. So we've got a pond. Just like when we were dealing with our topo, we can add in an image if we'd like. So we can right-click plan, backgrounds, we'll click the plus. We can add in that image we've already downloaded, or we could download it again, but we've already got it, so we might as well include it. We could, or we should note that the image that I have here is shifted to the top. So the draw order is that image gets drawn first, and then the topo gets drawn next. So if we want to see our contours and all that good stuff from our topo, we'll want to see it that way. And then there's other things in here that are useful. We can turn snapping on to the background feature, adjust our washout, and even override the colors of a entire background if we'd like to see the way it's represented. There we are. And actually, I'm going to just we'll make that gray instead here. And if we want to cut a cross section across this, home, new feature, again, just to reiterate that drape function. Mouse, we'll draw it in. And there's our section. So that is a pretty comprehensive overview of working with terrain for design, modeling, working with layers. We've built our IOP. Certainly enough information to cover a lot of project types.
Awesome. And with that, thank you, Matt, for today's demonstration. This is kind of the part of the webinar we transition into tackling a few questions. We haven't left ourselves a huge amount of time, so we'll tackle a couple. But if you have a question, open up that question section of your GoToWebinar panel. You can type it in, and even if we don't get to yours, we will get to it, just not in the webinar itself. So happy to answer any questions live or as a follow-up afterwards. With that, Matt, there are a couple in the chat. The first question for you today, does Rodange handle GPS survey data that I collected in field?
Totally. So really I used total station interchangeably for this one. This one is likely actually GPS data. We've got real coordinates here. So it's georeferenced in UTM 13. So this would be like your RTK survey data set. Now, if you're referring to kind of your conventional or consumer side of GPS data, we absolutely work with that as well. So in here, we've got a bunch of formats. So common GPS formats, well, you usually export them as a CSV like we had there, but KMZ, GPX, etc. We've got our bases covered for common formats. So hopefully that answers your question. Short answers, absolutely.
Yeah, and I just want to also note, see this one in the chat, the video, I know Matt goes fast. So the video for this webinar will be posted up to YouTube. You should all receive an automated email link once it's there. And with that, Matt, do you want to do one more?
Sure, yeah, totally.
This one's a bit of a loaded question, but let's try it anyways. What other types of site design tools do you have in terrain?
Oh, that is a loaded question. yeah, it's all, well, it's all either modeling existing or modeling future, or yeah, modeling past, I guess would be the other aspect for as-builts. So yeah, site design stuff. The grading tool is going to be a really useful function. Auto balance with that is a useful function, but really it's complete. We can draw in lines and basically draw whatever we'd like in 3D. I guess the one thing I'll kind of backtrack a bit on though is terrain is very well suited for your bulk earthworks side of things. Road eng is well suited for your cross section, or sorry, center line with a cross section geometry attached to it. So your classic linear infrastructure design. If you're doing things that are better represented as a center line with cross section geometry attached to it, you'll want to use road eng instead of terrain. So yeah, ditches, roads, pipelines, yeah, trails. They're more friendly to tackle in location than terrain. Hopefully that answers your question. If there's any specific aspect to that you'd like me to elaborate on, please let me know. Yeah.
Awesome. Okay, that was actually a shorter answer than I anticipated. So let's do one more,
Okay.
which is, can I save that import settings so that I don't have to do it again?
Yep, totally. And this one here, so I believe I hit the save button, but I'll hit save as default. Now, when I do that, it goes in and it's named normal.iop in this default system directory. If I was working anywhere that I had colleagues and they were doing the same thing and I didn't want them to have to redo it, I'd hit save as default and give them my normal, or save as something new and give them my normal. So if you were the colleague getting someone else's IOP file, you could click open, and if you clicked open, it's going to replace everything that's here. But if you clicked merge, it's going to add any IOPs that you don't already have into your list. And then, yeah, assuming what you're given is useful, rather than merging it in every time or navigating to it every time, just hit save as default, and no need to worry or really think about it. Caveat of thinking about it, in this case, with that IOP that I have set, my default is set as a black dot. So if I were to have brought that survey data in and notice a bunch of black dots, it's probably because I don't have a point code named to match it. And we can click on it, we could see the name of that actual feature, and if it's something that we expect to see again, well, we can update that IOP and hit save as default again. So absolutely can save it and can share them too.
Awesome. Well, we're 4 minutes over. I think we're going to wrap up there. We'll tackle that extra question or two through email following the webinar. But I wanted to thank you, Matt, for today's presentation, and thank you to all of our live attendees and those of you watching this off of YouTube in the future. Have an awesome rest of your day.
Thanks, everyone.